Hello 8th grade, my name is Mr. Rogers and you're watching the video lecture for section 2-3 in your book there on forces here, that book on forces. So today we're talking about these three things: how to define Newton's third law of motion, number 2, define and calculate momentum, and number 3, state the law of conservation of momentum, which we've talked about the law of conservation of different things before, and momentum will be much in the same line as to how it works. And Newton's third law of motion, it really explains so much around us as to how things work and interact. And it's one of those great ones that when it come across it, when it was discovered, and it just helps explain so much of the world around us. So, momentum and Newton's third law of motion. So Newton's third law of motion says, if one object exerts a force on another object, then the second object exerts a force of equal strength in the opposite direction on the first object. That's a lot. That's a mouthful right there. So break that down. It means forces come in pairs. For every action, there's a reaction. For every push, there's a push back. So when you step on the ground, you push down on the ground pushes back up on you. You push against the wall, you're pushing on your iPad or iPhone, that screen is actually pushing back on you. Otherwise, your hand would go right through it. So it seems kind of weird that for every action, reaction, when you sit down in a chair, you push down the chair pushes back up on you. If the chair is broken or you're too heavy, the chair might comically break. So Newton's third law explains the idea of action and reaction. But also think about when we launch shuttles or rockets into space, that jet fuel is burning, it's propelling downwards, that reaction is up. So action and reaction. When you fire a gun, the gas, as the gunpowder is ignited, pushes one way, the bullet pushes the other way. So action and reaction. So Newton's third law talks about things come in pairs. And what I'm going to do, I'm going to stop here for a second. I'm going to have you watch a video that's going to be right about here. I have a link for it. And it's about the first time that an American was out in space trying to do actual work, trying to put something together. And it's what happened to him while he was in outer space. So it's a cool little video. It's from the 1960s. But it's interesting to see, as smart as we are, the first time we went in space, this Newton's third law of motion really kind of kicked us in the behind. So it's going to be right here. I'm going to take a minute, let you watch it. All right, we're back. So pretty cool video, huh? The idea that he's out there spinning around, he's sweating like a pig, he couldn't do anything because he forgot Newton's third law, action, reaction. He had to be anchored to something for this to work. So, secondly down there is the idea of below. Next video I want you to watch, it's going to be a link here in a second again, is the idea of Newton's cradle. And you've probably seen a Newton's cradle before. It's a series of the 5 balls lined up and they go back and forth. And again, I'll have the video clip right here in a second. And just kind of showing that how the action and reaction is equal and opposite there. So you have a push and a pull for how those work. Again, the link is right here somewhere. I'll wait. And we're back. All right, so let's move on with our notes, guys. Down below here we have the idea of momentum. And momentum kind of means the quantity of motion. We can say momentum is the amount of motion something has. So when we try to calculate it, we calculate it with the mass and velocity. So mass times velocity will give us an object's momentum. So a change in an object's mass or velocity, again, will change an object's momentum. And so the more mass you have, the more momentum. The more mass, the more velocity, the more momentum an object will have. And we often use that term when something is picking up speed, it's gaining momentum because it's increasing velocity. A snowball, think about a snowball going down a hill, it's getting bigger because it's gaining more snow, and it's going faster, so again, it's gaining momentum, it's getting bigger, and it's getting more mass, so momentum is going to be increasing before it hits the ground. That's the idea of momentum. And we can apply this to the law of conservation of momentum, which we've used this term before, but again, it says that the total momentum of objects and interactions does not change. It has to go somewhere. And I refer back to that Newton's cradle video you just watched. And again, it shows how that momentum has to go somewhere. That ball has momentum, it travels through the other 3 or 4 balls, and it comes out the other side. So that momentum is transferred but not created or destroyed. It's got to go somewhere. So the idea of the law of conservation of momentum is that the total momentum of any group of objects remains the same unless outside forces act on the object. Something's got to change that momentum. It's got to be transferred somewhere. Think about a car accident. That momentum is transferred from one car to another. A lot of times brakes are involved and there's friction, so it slows down and stops. But that's transferring momentum. Another good way to kind of show this is with an example here. I'm going to show you another video clip, and it's really kind of the coolest one I could think of here. It's a Mythbusters clip, and they're going to be describing, the old Hollywood myth that when people get shot, they have the giant guns and they shoot them, and the guy goes flying backwards and falls down. Can that really happen? The idea, kind of think about these two laws we just talked about, where forces in Newton's third law have to be equal and opposite, and also the law of conservation of momentum, where we can't create or destroy momentum, it's got to go somewhere. And so as you watch the video clip, think about these two ideas of momentum and also of Newton's third law, that if the guy firing the gun doesn't get blown back, can the person or object getting shot, can they all of a sudden receive this momentum from nowhere? So I'm going to, again, have the video clip somewhere off to this side of the screen right here. If you want to jump ahead a couple minutes, you can. It's kind of the intro of the Mythbusters, so you can jump ahead to like minute 4 if you want to and watch it. And I will wait here while you watch, and we'll come back and wrap it up. Okay, that should be enough time. So again, kind of cool how the idea that you can't do that. You can't just create momentum out of nowhere. That video shows you can't create momentum. It's got to come from somewhere. If that person's not getting blasted back by the gun, the object being shot will not be blasted forward, because that momentum can't come from nowhere. There's not an equal and opposite reaction. So that's a really cool video to kind of end with, because it really describes and put these two ideas together. So I thank you guys for watching today, and we will see you along the way.